All right, there's your math answers from last night. Does that work? Okay. I don't want you to just copy it down. Okay, EJ, don't just copy the answers down. Do it tonight. Page 75, lesson 4-1. That was your homework last night. You were supposed to do the evens. Diesel, please join us. Done all of those, so you should have done some of those. Let's see what it's like. Perfect. Yeah, so guys, so here's the thing. When we correct our homework, instead of just marking it wrong, I would rather you fix it. Right? Instead of just marking it wrong, fix it. Because just marking it wrong is not going to help you know what you did wrong. But if you try it again, you might be able to figure out what you did wrong. And now that you can see the answer, that might help. Also, I will now ask for questions. If anybody has questions, I would be happy to show you how to do any of the problems that we did last night. Are there any questions? Yes?
I don't get number 14.
Number 14. So, if the tortoise lives to be 100 years old, how many miles will he walk? Well, we had to look back up here to number 13. And number 13 told us that a tortoise walks 27 miles in a year. So I have 27 times the 100 years old, which gives me 2,700. Other questions? All right, let's look at the other side. Oh, I can just barely fit them all. And usually I give you guys a minute to correct. I don't start taking questions right away. So you don't need to sit there with your hand in the air getting a sore shoulder. Okay, I will ask for questions. I want to give you a chance to go through all of it first. Any questions on this page? So hopefully we remembered how to find our multiplier or our divisor. We look and we see how they got from one numerator to the other numerator. So for example, on number 4, how did I get from 2 to 20? Well, 2 times 10 is 20. And then I check to make sure that works for the bottom too. Is 3 times 10 30? Yes, it is. Therefore, my multiplier is 10 because I multiplied both the top and the bottom by 10. Okay? Divisor just means that they divided to get from the fraction on the left to the fraction on the right. Okay? 9 people out of 1,000 gives me 9 thousandths. And then I had my multiplying down below, so just remembering that the whole number has a 1 as a denominator. It's just hiding. It's kind of shy. All right, no questions? All right, we're going to set this book aside, take out our student activity books, page 119. Page 119. Question? Who's that for? Is that you, Neil? Don't worry. Oh, no, it's... What time is it? 11:30. 11:30. I don't know what that one was. Let me see who it was. Miss Worth. Anybody go to Miss Worth right now? All right. So, now we're ready. All right. Powers of 10. So I told you guys yesterday that this first lesson, I kind of divided into 2 sections, right? We're still on lesson 4.1. Because the first part was covering a lot of the multiplying and the shifting and all of those types of rules. She's on her way. Yeah. Okay. So it was the shifting and how many places based on the zeros. And today is something totally different. So I'm not sure why they shoved both of these into the same lesson, but they did. And so that's why we broke it up into 2 parts. Okay. So we are on lesson 4.1, page 119. And the second part of this is talking about powers of 10. Powers of 10. And when we look at powers of 10, there's some vocabulary that we need to look at. So expressions are just like multiplication problems that don't have an equal sign. Expressions with repeated factors. So see how it's 10 times 10 times 10? It's not 10 times 2 times 36. I'm repeating the same factor. It's always the same factor. 10 times 10 times 10. 2 times 2 times 2. 8 times 8 times 8. 346 times 346 times 346 times 346 times 346. That one was pretty exciting, huh? Doesn't matter what it is as long as it's the same factor being repeated. So expressions with repeated factors can be written by using a base with an exponent. Okay? The base is the number that's used as the represented factor. So in this case, when I had my 10, 10, 10, my base would be a 10. The exponent is the number that tells you how many times that base is used. How many 10s did I have? 3. So it gets a little teeny tiny 3 right up here. So my base is the 10, just like they show you here. My exponent is the 3. Yes?
Could you do it more than 3 times?
Absolutely.
And if you only did it 2 times, you wouldn't have to do anything?
You still need an exponent if it's 2 times.
Well, would it would be like 10 squared.
Right. So 10 times 10 would be 10 squared, or 10 to the second power. Jackson.
Can you make another number 10 to the power of 3, but the 3 also has another power?
I believe so, but you won't do that until you're in high school.
Oh, okay.
You can also have negative powers when you get to high school. Yes. Oh, Morgan, you're very excited about that.
Are we going to do any negative numbers in 50?
No, not anymore. We used to a long time ago. Okay, so let's get back on track. So here's the important thing, though. Here's the important thing. If I wanted to solve this, 10 to the third, what do you think my answer would be? What do you think my answer would be, Jaslyn?
1,000.
Jaslyn says 1,000. Does anybody think it's something different? Go ahead, real quick. You are correct. You are super duper smart. Thank you for saying that. A lot of times, kids, and must not be in this class because you guys all got it. Those of you that are doodling with your pencils, let's put your pencils down right now. A lot of kids would say, oh, 10 to the third is like 30. 10 times 3, that's 30. But it's not, because remember, 10 to the third is the same as 10 times 10 times 10. This is also not 30. Put your pencil down, please. 10 times 10 is 100. 100 times 10 is 1,000. So 10 times 10 times 10 is 1,000. Okay. When you represent a number using a base and an exponent, we call it exponential form. If I come look at your books, those of you with your pencils up, I hope I see that you're writing down what I'm writing down. If you got it, you don't need to write this down because this is the exact same thing, really, that's right there. Okay? Exponential form. So if you're asked to write something in exponential form, it's the number, the base with the exponent. That's what we call exponential form. You know how we have standard form and expanded notation and all of that stuff? This is exponential form. Word form would be two different ways you could do it. You could say 10 raised to the third power, or the third power of 10. Those are two different ways that you could say that. Okay? So down here they want us to write each expression as repeated multiplication and solve. So if I have 10 to the second, how many tens am I going to be multiplying? Show me on your fingers. How many tens am I going to be multiplying? Some of you, I don't see any fingers showing me. 2 of them, because my power is a 2, right? So it's going to be 10 times 10. 10 to the second power, or 10 times 10. What is 10 times 10? Everybody? 100. 100. How about 10 to the 5th? Show me on your hands. How many times am I going to write down that number 10? Those of you that say 5, how do you know it's 5?
Because it says 5. Because the power is 5.
Because my exponent is a 5. So I'm going to write 10, 10, 10, 10, 10. 1, 2, 3, 4, 5. What's my answer going to be?
100,000.
100,000. How many zeros are in 100,000?
Oh, wait, no, 5. 5.
What was my exponent? Oh. When we did 10 to the second, what was my exponent?
2.
How many zeros were in my answer?
2.
Oh. When we did 10 to the third, what was my exponent?
3.
How many zeros were in my answer?
3.
Oh. Looky, looky. We might have found a, here's my favorite word from little kids. We might have found a pattern. They say pattern like pattern a lot of times when kids are little. It's a pattern. Like they've got their pack instead of their backpack.
My brother used to say 10,000, 10,000.
Nice. All right, 10 to the fourth. How many tens am I going to multiply? Everybody.
4.
4. 1, 2, 3, 4. How many zeros is my answer going to have? 4. So I've got a 1 with 4 zeros. Ooh, 10 to the first. It's just 10, right? Which is just 10. Morgan.
So for the exponent, could you have the like the same amount of like 10 times 10 or like 10 with times 10?
10 to the 10th?
Yeah.
Is that what you're saying? Yeah.
And could you have it more than the base number?
Yeah.
Like 10 to the 100.
Yep. Other questions? Jaslyn. Oh, we forgot to stand up.
Do we have to have the 1 on that as an exponent? Because there's only 1
You don't have to, but if they put it on there, then you need to know how to solve it. Diesel. Stand up for me, please.
Shouldn't the first part for 48 be 10 times 1?
Nope, it's just 10. Because it's how many times you have that number as a factor.
Yeah, and then 10 times 1 is 1, which the 1 would be showing the 1 beside.
There's not a 1 though, it's just a 10. Not so, there's not a 1. All right, use an exponent to write each repeated multiplication. So this one is a little trickier because I have 2 different factors, don't I? So I'm going to need to write down my 5 because I don't have anything repeated for my 5, right? So I'm just going to put my 5 times, here's where I get into the repeated part. I have 2 of these. So what am I going to have? 10 what?
10 and your exponent is 2.
5 times
10 to the second. Yes. How about my next one? I've got just the 1, 3 times. Now I get into my repeated part.
1, 2, 3, 4.
10. How am I going to say it?
To the 4th.
10 to the 4th. Question?
Yeah, can we do that on our homework instead of writing the entire equation? On our homework page if we have it.
Well, it depends on what it's asking you to do. So yeah, if it's a situation where you can do this, then absolutely. Diesel.
For my 49, I didn't really write like 5 times 10 to the second. I just did 5 and then 100.
But so you're not doing what the directions are asking you to do though, so it would be marked wrong. Because they want you to use an exponent to write the repeated multiplication.
Honestly, I just got yours supposed to be first.
Nope. That's why we got to read the directions. Jaslyn.
I did read it.
Good, why don't you do it?
For number 52, I was just looking at it.
So you could do 2 times 10 to the first or just 2 times 10. Just leave it the same. Finish these out. Do 51 through 54 for me. I know, a lot of you probably already did finish them. Let's see, 9 times 10, 1, 2, 3 times. 7 times 10, 1, 2, 3, 4, 5 times. 1 times 10, 1, 2 times. Compare my work to yours. How'd we do?
Wait, is that 105? I got something.
I don't have 105 written anywhere.
Oh, sorry.
All right, let's keep going. All right, multiply 3 by powers of 10. Look for the pattern. So 3 times 10 to the first is like 3 times 10, which gives us 30. 3 times 10 to the second is like 3 times 10 times 10. What would that give us? Everybody. 300. 300, yes, because 10 times 10 is 100. So 3 times 100 is 300. How about 3 times 10 to the third? 3 times 10 times 10 times 10. 3,000. And on the last one, I have 30 times 10 to the third. Look at how they broke down the 30 into 3 times 10. Do I really need these parentheses here? No, it's multiplication, so we can just multiply across. But I now have 3 times 10 times 10 times 10 times 10. How many zeros am I going to have? So, thank you to those who listened to my question instead of just shouting out, because I don't think I'm going to have 30,000 zeros. That was not the answer to the question I asked. I asked, how many zeros am I going to have? 4. A 0, 1, 2, 3, 4. So a 3 with my 4 zeros. 30,000. Okay? So, what do you guys notice? What pattern do you see? Let's look for some hands here. What do you see? EJ?
We added 10 every time.
Okay, we add 10 every time?
Or like they add like a times 10 every time.
Yes, we added a multiplying by 10 every time. Oh my goodness. Who is she calling for? Go ahead, Mason, what'd you notice?
So I noticed that each time on power 10, so like let's say I had like 3 to the power 10, it would 3 behind the put.
Okay. Gabby, what'd you notice?
It has 1 0, then it has 2, then 3, then 4 zeros.
Okay. Jaslyn, what'd you notice? I noticed that we're not standing up when we're answering.
I noticed that every time we added a 10 to it.
Okay. We added a 10?
No, we multiplied. Well, I mean, like we added a 10 into that.
We add another factor of 10? Okay. Corey, what'd you notice? Same thing. Morgan, what'd you notice?
I noticed that the exponent is the number of zeros, and then the other number, if they have zeros, we just add that one.
Awesome. Jackson, what'd you notice?
The answer always.
Stand up for me.
The answer always goes up by 1 0.
Okay. By a power of 10. I noticed, just like Morgan, how I started with whatever my my non-power factor was, right? My factor that's all alone, so like my 3 here. And then whatever my exponent was, that's how many zeros I had. So I had a 3 with 1 0, a 3 with 2 zeros, a 3 with 3 zeros, and a 3 with a 0 from there and 3 from there to give me 4 zeros. So if I come down here, let's see if that's right. 1 times 10 to the 4th, is that going to be a 1 with 4 zeros?
Yeah.
It is. 2 times 10 to the 3rd, what's that going to be? A 2 with how many zeros? 3 zeros, because it's 10 to the 3rd, 3 zeros. 62 times 10 to the 2nd, what's that going to be? A 62 with how many zeros? 2 zeros. You guys think you can fill out the rest of this down below?
Yes.
Do it. Carter, are you working? Oh, make sure you're paying attention to what the blanks are asking for.
Office, have you received the gifts that students got from PTC who won the pumpkin carving contest? I have a few students asking. Yeah, we've got 2 that are left.
Yes.
On number 60, they're asking us to write an equation.
Take a look at mine. We're just mirroring the exact same thing they did on 59. Please make sure you're putting your commas in your answers in the correct spots. My goodness, it's hard to get to the ones over here on the far side. I'm going to write this one down here. Check your work with mine. Make sure I did it okay. Hello. All right, even if you haven't finished it, check what you've done so far with mine. I'm okay if you don't finish it all the way out. Take a look at your work compared to mine and see how it looks. Nope, another class is out there right now. We can't go. All right, so homework tonight are the odds on the same 2 pages from last night. Okay, so yesterday we did the even, tonight we do the odds. So you are on pages 75, 76. Again, make sure it's that lesson 4-1. Page 75, 76, you are doing the odds. Yesterday was the evens. Same page as last night, 75, 76, but today we're doing the odds.